And the whole idea here is before, if you recall, with the single function, we found area under the curve. Oops. From A to B, we found the area under the curve. Right? Well, not anymore. Because now we're going to have a function of x and y. And we're going to integrate it over some area. And we're going to do double integral. Go from A to B, C to D, or what have you. Means, in other words, looking down at the x and y axes, you're going to go, let's say, from A to B on the x-axis, and from like C to D on the y-axis. So you'll be integrating over this area. Picture this. You've got a surface up over the top of that mess, and you're just going to come down with this, kind of like just drop straight lines, come down from your surface. And so what you're going to end up with then is volume.
Volume under a surface.
Yeah. That's it. That's all. It's easy money. Now, that's literally all it'll ever be. The only thing we'll ever do differently with double integrals, I mean, that's it. The only thing we're going to do when we talk about them is going to be a variety of different issues. So they won't always be a nice rectangle down here. It'll be different things. We'll have to screw around with that. Sometimes it'll be a, oh my God, it's like a circular region, Mr. Groom. How weird is that? Yeah, exactly. Well, we have things called polar formulas, polar functions, right? Or you can do a nice polar integral to make it even nicer because it's based on the area that you're integrating over, okay? But in reality, it's all double integrals ever are going to be finding volumes under a curve. Just like regular integrals, just finding area under a curve. What?
So in your notation for the double integral, you said dA.
Yep.
I've also seen it written dx dy. Is that equivalent?
Well, I'm getting to that. You're ahead of me, but yeah, exactly. Exactly. So, exactly. So it ends up, well, but here's the deal. So if you have your region down here, again, from A to B, from C to D, if you cut it this way, you see dx's, yes? Right? And there's a bunch of them, whatever. And you cut it this way, and you see dy's. And this little fart right here, if you zoom in on it, nice. This little fart right here is the area. And so dx dy, which of course is the same as dy dx, why? It's freaking multiplication, and multiplication is commutative. Exactly why is equal to this. And then a fellow by the name of Clairaut, I never spell it right, so, or something, said that it's equivalent either way. Okay? Later on, when we do triple integrals, it'll be dx, dy, dz, dy, dz, dx. Notice that there's 2 ways to do this one. Later on, there'll be 6 ways. But they're all equivalent. Why don't you do it 6 ways? You don't. And why would you? Because you'd be an idiot to try that. Although one time on a test, first year I taught this stuff, I thought it'd be fun on a test. Do it all 6 ways. Yeah. Yeah. And you're like, well, it wouldn't be that bad if it was from A to B and C to D and all that. It wouldn't be, but it wasn't. It was bounded by these lines, and oh, it was a freaking mess. And oh, and they were crying and moaning, and oh. Yeah. So, today we start off with a nice rectangular region. And so we're going to find, we have some function like this. And we'll do a nice easy one first. We're going to integrate it over the region. When it's written in this format, it's x's by y's. That is the x region, that's the y region. If you're looking down the xy plane, here's 3, here's 4, here's 7, here's 11. It's that region in there was what we're interested in. Okay? So, the double integral looks like this. Okay? Your choice. I prefer dy dx. I don't know, it rolls off my tongue better, but you can do dx dy, whatever makes you happy. I guess I'll do it that way this time, then no one can accuse me of being biased. I'm sure there's some sexist reason in there why I do dx dy first to dy dx.
Well, actually, the male has the Y chromosome.
There you go. That's it. There it is. What a misogynist. All right, there it is. So notice I'm doing x first. What this means really is this. You're doing the stuff in the parentheses first, in essence. Okay? Okay. So what we're going to say is this. If you integrate 3x squared y with respect to x, what do you get? You don't need a calculator yet. Let's do this by hand. Let's just do it by hand. Let's just do it by hand. X cubed y. Over 3 if you like. But x cubed y. Right? Plus x squared y. Plus what? Nice! Nice! I thought I would fool you. I did not. Shh. Red, be quiet. You're a little loud. There we go. Nice. Wait a minute. That means if I come in here, I'm going to get 64y plus 16y plus 24y cubed minus. Hey, what's up, Mr. Ford?
I was just gonna stop by and say hi.
It's good to see you.
I'm gonna go run some other errands.
All right, come back later.
I will.
Right? So if you combine them, 64 minus 27 is 37. Oh, why did you do that? Well, I can do this too. 9 minus 6, 16 minus 9 is 7, so plus 7 is 44 of them, I think. You should check my math, but that sounds right. It's 80 minus 36. Yeah, it's 44 y's. There we go. And then plus 6y cubed. So all of this business in here comes down to that guy right there. Now we're going to go from 7 to 11 dy. So 22y squared plus 6y to the 4 over 4. And I can't do that in my head. I don't care. Okay. What do you get? Bust it out. What do you get? Well, I don't know. Come on, you all have TI-87, or you all have the iPhones. There must be an app for that. Anywho, when it's over a nice rectangular region like this and your functions are decent, it's not hard to do by hand. Okay? This is probably the only one I'm going to do by hand, Donovan, because, well, Donovan, they get gross after this.
Yeah,
What's the matter, Donovan?
I was just remembering how to integrate.
Okay. You just look like you're sad, so I need to give you a hug or something. Or Donovan need to pick you up and throw you or something. I don't know.
I
Right.
had it.
I got a very large number.
Well, by the way, are we shocked?
No.
No. To be a monster. What'd you get?
23,472.
23,472. Doesn't seem that large, but that's cute. It's big. Yay! What would that be measured in?
Cubic units.
Units cubed. Very nice. Doesn't matter. Don't care. Scrim, would it be the same if I integrate the other way? Yes, but let's do it. We're going to do it by hand. Yo. We'll do it by hand. Read it to me. Was it 3x squared?
3x squared y plus 2xy plus 6y cubed.
And from where to where? First, 7 to 11?
7 to 11 dy.
Okay. So with respect to y, it's going to be 3x squared y squared over 2 plus xy squared plus 6y to the foe over foe. Notice this first step will not look the same because you're going about it from a different point of view, but the final answer better be the same. Yeah. So, screw it, I don't care. Make sure you're plugging that in for y only. So evaluate it at y, that's great, whatever, but only y. When I'm done, I'm going to have x's left over. What do you get?
108 x squared plus 72x plus 18,360.
18,360.
Yeah.
That's awesome. All right, dx. So of course that's going to be 36 x cubed plus 36 x squared. That's hot. Plus 18,360 x from 3 to 4. And we still should get 23,472.
Well, the first
It's
time
actually 19,000.
yeah, the first time we did that, I got 19,944,
That's what I got.
and then I got the same answer after we just did it again.
Yay! Cool. Point is, they should match. That's the point. That's the takeaway.
Right.
So, take your calculators. This is how you do it on a calculator. And yes, it's 99% of the time I want, well, we're just going to do it on a calculator almost every time. So I'm going to, oh, now I got to scroll up. Okay, I'm going to do this first one first. I'm going to do dx dy first this time. So, you're going to do integrate 3x squared times y plus 2 times x times y plus 6y cubed, comma x, comma 3, comma 4, parentheses, comma y, comma 7, comma 11. Boom. Done.
So that's still
You just nest them. You just nest them. And by the way, how I do this parentheses around there like that, straight up how you put it in the calculator. But you're going to a triple integral. And then I feel like you do this. Or whatever. We DZ or something. Yeah, exactly. Just nest them and let's go. That is not the hard part. The hard part is always figuring out what the bounds are. Because they won't always be a nice rectangle. That is by far the hardest part. Any idiot can punch it in. Right? Heck, any idiot could probably integrate it. Probably. If you gave him enough time. It's hard to say though. So you'll see one like this. I don't know. 3xy minus 2 x sine xy or something. I don't know. Minus 3. Now notice that they will always write it dA right here. And then they will say, hey, look, let's integrate over some region. So like negative 2 to 4 and 3 to 7 or something. I don't know. Not even going to try this on my hand.
yeah.
Don't care. Look, I literally don't care.
X sine x y.
So integrate,
Very good.
integrate, and then 3x divided by y minus 2 x times sine of x times y minus 3. So I'm going to do, I'm not going to tell you what I'm going to do. I'm just going to do my own thing. I did dy dx, and I got, bam, oh, I got that. Oh, make sure you're in radians. Don't forget to be in radians. Okay. And boy, I pissed her off this time. Here. Well, I have the answer. I just got, what I just need to do is just evaluate the answer. There it is, negative 55.8. And so what I really want to see when you do these is,
Yeah. Took a while.
and I did dy dx this time. So actually show that. Negative 55.8 or something. What did that mean, negative volume?
So it's on the opposite side of
Opposite what line?
the 0.
Not line, opposite side of the xy plane. It's a hole in essence, yes? How much dirt you've taken out of the hole, how deep the pond is, what have you. Now, this leads me to our next project, although some of you saw them turn in the first project or the last project, but whatever. We're going to be starting a new project soon. And the new project will be, you'll come up with some kind of a graph. Well, that's cool. Just any graph? No. It's going to need to have a maximum, a minimum, and a saddle point. Nice. And then you're going to model it out of clay or sand or what have you, toothpaste, marshmallows, I don't care. And what you'll end up doing is you'll find the volume under it, you'll find the surface area of it, which we haven't got to yet, but we will. We will find the gradient vector on it at some point, the tangent plane at some point, and so on and so forth and whatnot. Basically, everything we've done in chapters 11 and 12, you'll put on said function. Okay? A few years ago, this kid made this form. Anyway, so then what you'll be doing is this. So this kid made this surface last year. This kid printed this one out. This one, those are the prints. This one was made by a student, which I kept because it kind of made me happy in that it's as if you've got a function where you got height, that's which would be your z values, yes, and you got a little dx, a little dy, and so a height times a delta area gives you volume. Oh my God, it's just like we did midpoint. Exactly. And so we'll have midpoint, and Mr. Green, will you show us how to do that in Excel too? Because a lot of times you'll get something so gross your calculator can't do it or it won't do it, and it'll just say, screw you, I'm done. Okay? And so when that happens, not if, when it happens, then a person could, for instance, do this. Now, I'll show it to you today, but we'll do it again later on. Most of the time that'll happen when we do surface area. Do you recall when we did arc length, it was the square root of a bunch of crap squared? Mm-hmm. Surface area is literally the same, except that instead of having one thing squared, it's a bunch of crap squared inside of a square root. It almost never integrates. You leave your calculator sitting there for a couple of days, you come back, it might be done, or it might not be done. So, in Excel, this is the way to do it. Now, what was our x coordinates? What did we start from? X went from where to where this time? Negative 2 to 4. I want to use 100 data points in there, yes? 100 data points. So let's think about that for a minute. From negative 2 to 4 is a distance of how far? That's 6. If I do 100 boxes, then my delta x would be 0.06, yes? Where would my first midpoint be? It would be negative 1.97, correct? Right? So over here in Excel, I'm going to put in negative 1.97. Because that's the very first midpoint.
It's half.
So negative 2, go over 0.06, come back halfway, what happens? So it's this fella plus 0.06. And of course, we drag that over to, trivia question, what value? You're wrong, it's CW. Bam! See, I can be just as nerdy as you fruitcakes. Just as nerdy. No, because I've done it a few times. All right, here we go. And then, so then for what about this one here? We're going from 3 to 7. So that's a different distance of 4. If I do 100 again, that's 0.04. So 3.02 is my first midpoint. And by the way, those of us who are going to major in math will learn that this is not the only way I'm doing. I like to do the midpoint because it's the easiest one. But there's actually a variety of numerical methods classes where you could talk about all the rest ones. And you could this one or that one. At that point, I'm just like, I don't care anymore. It's good enough for government work. No, it's not Simpson's rule, but you get the picture. It's a whole bunch of similar dealios. There we go. Whee! Come on, get down there. One more, stupid. Yeah, babe. I know, right? By the way, how'd that go this morning? Oh, yeah, never mind. You told me that's right. Anyway, so watch. Equals. Now, what was my formula? Was?
3x over 1.
3x. So 3 times x. I want to keep that in the top row, so I put the dollar sign where? On the 1. There you go. And then divided by y. I want to keep that in column A, so put it there. And then what?
Minus 2x.
Oops.
To make sure it stays at the top.
Ah.
Yes.
-3?
-3.
That's pretty cool. Give it one of these. Whee! Grab it. Yeah.
This side function like that too, where you
Yeah.
can, like,
That would be nice.
You can
I'm sure there's probably some fancy way already built in, just Mr. Cream doesn't know it.
boom.
Okay? Now, what do I do with all that mess? First of all, by the way, notice that a lot of them are negative. So that's probably why we have a negative. But what else? We're going to do this. We're going to say equals the sum of what? The sum of what? B2. B2, right? To where?
CW.
C dubs, 101. Bam. And then what are we going to times that by? Delta x and delta y. But delta x times delta y form your delta area. Which in this case would be what? 0.04 times. Holy buckets. Now again, yeah, but I only used 100. One time last year, I thought it'd be kind of fun to try it, so I did. I went 1,000 by 1,000. That's a million, by the way. And it took a while to crunch all that. And Betsy was not pleased with me. She was very angry. She whirred and grunted and groaned, and then she finally spit the answer out eventually. But it was actually, well, not surprisingly, pretty good. Okay? Because he's a teeny tiny little boy. Yeah, how about that? Well, now I pissed her off.
the dial-up sounds.
All right, well, what I'd like to do here in a second, if Betsy'd ever freaking get there, is I want to actually graph this. I want to actually, I want to put colors to it. See what it looks like that way. If it would hurry and do it. Nice. Hey, Al Gore hasn't invented the internet yet. What? I really want to do this. The way I done it now. All right.
Those darn kids on the Wi-Fi.
All right, turn that thing off. That's getting a lot annoying. All right, now. See if it did it find itself? No, it didn't find itself. Crap. All right.
Not yet found itself.
I gotta do it again. Because I want you to see this. This is exciting. So, what is it? Negative 1.97?
Oh, you're on a certain B.
What? Oh, for God's sakes. Oh, 06?
Yes. Yes.
Oh, I hate you. Come on. Why aren't you going? Let's go. There we go. Bam. Equals, what was this one? 3.02? Plus 0.04? All right. All right, so Levi, to answer your question, you can do it the other way too. So what was it? Equals 3 times x divided by y minus 2 times x times there's something on my keyboard times sine of x times y, there you go. And then what? All right, so if you're smart, you can do it this way too, is drag it sideways, and then, oops, then you can double click it down. then it will fill down that way.
You still have to track them, right?
Yeah.
Well, I guess you'll live with the other side of this.
Bam. Okay. Now, so what you can do is, if you come in here, you can do a couple things. First of all, if you go to Insert, Insert Chart. If you go to Recommended Charts. Oh wait, except I need to. This means I got to highlight everything. I go. Oh. You kidding me right now? Okay. 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 Let go. Just cancel. Just cancel. There you go. Okay, I'm going to highlight everything. I want all the numbers highlighted this time, all the way back. Maybe not.
I would just click in one corner.
It just hates me.
Shift click the other one. I think that would be like
Will that do that for me all the way across?
Yeah.
It will.
Yeah.
So here, and then what?
Go down to the bottom right corner.
Oh, it's here and just start.
No, go to the bottom right.
Yeah, right here.
No. It's like the bottom right of your whole spreadsheet.
Yeah, but use the scroll bar.
Yeah. Oh. He doesn't want to answer your question.
Hold shift and click.
Right here?
You have to hold shift when you click.
Oh, you mother pearl. All right, just screw it. I'm going this way. I should just get my mouse out.
If you zoom out.
I'm just getting my mouse. I don't care.
I think it's hard to work.
It's not the best for spreadsheets.
I tried to use it.
It is less than useful some days. All right. Are you saying something to me, Zach?
I was gonna ask him.
Well, I'm kind of in the middle of something here. Hang on. I'll be with you in a jiffy. All right. Freaking A. Let's go. Oh, that's too far down. There you go. See dubs. Okay, go back up, 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 up. There you go. What? Okay, great. Now, cool. Insert. Okay, so I like to go to this recommended charts because it's the fast way if I can find to get to it because I don't know where the rest of the stupid thing's hiding. It's not important to me. Well, it could be under the 3D maps too, but if this doesn't work, I'm going to punch it in the face. If you go down here to the surface, right here,
Box into this.
you can actually graph a surface for you.
Hey, that's pretty sweet.
Okay. Bam. And if you unzoom a little ways, you can see it better.
No, it's at the bottom right corner.
It's down there. There it is. And then if you right click on it, you can actually rotate it by doing some of this action. Yeah.
That's pretty sweet.
So it's pretty cool. It's kind of neat how it works, whatever that way. But another way to do that, another function I think is pretty cool on these, if you go to Home tab, you can actually, oh wait, I gotta be back on, oh! I hate you. Okay, no, we're good. But it won't let me do it now because it's highlighted. God dang it. Oh well. Here, click on the dumb, get rid of the chart. All right, I just want to show you that we can actually see the same basic premise just by conditionally formatting it. Which is kind of what I wanted to say in the first place. Well, that's good enough. I don't care. Screw that. You get the picture. It's not that big a deal to me. Okay? And if you just let it do its thing, it'll actually color it for you. And it'll decide what things are where. And then you can zoom in
Whoa.
and actually see some pretty cool stuff on it. Now, you zoom out a ways, as I say, you can kind of see it, and then you can zoom in and see it's green and dark, or it's green the negatives or the positives or whatever. So, by the way, pretty cool. Stand-up math, what's his face? Math Parker, the mathematician, did this a couple months ago. Took a picture, and then he put in the red, blue, and green, right? And he put them on there because that's all this is, and then just conditionally formatted it. And if you zoom way out, there's the picture. Same basic premise.
Did you show us?
Yeah, I think I did, but whatever. So there's that. Anyway, so that's kind of a neat way to do it, though. I think it's kind of nice. You can kind of visualize what's happening that way. Was there something else I want to say about that? Yeah, I don't know. That's enough. I don't care. So anyway, so we will be doing some, as I say, some volumes that way. If you zoom in, oh, I do want to zoom in and scope. See which one's which. So looks like the red or the darker reds are the negatives. Okay. So apparently we've got a lot of dark red negative pieces versus the other stuff. So, and again, if you saw what I did there, I did not highlight the X and Y values when you do this kind. But when you're doing the surface plot, you need them so it can graph them. Okay, but whatever. So we'll look at that a little bit more later on. Whatever. Oh, that's enough for now. So you got probably basically 3 assignments to be working on now, ish. So you got enough to do tomorrow. And we'll talk to some of these clowns. We'll talk about what they're doing tomorrow.